Download this code from codegive.com, link in the description below. OK, let's dive deep into the concepts of happy paths, sad paths, corner cases, and how to handle them effectively in your code. We'll cover definitions, examples, best practices, and provide practical code snippets to illustrate these ideas. Introduction to happy paths, sad paths, and corner cases. In software development, we strive to create applications that behave predictably and reliably. To achieve this, we need to consider various scenarios that our code might encounter. These scenarios can be broadly categorized into happy path, the ideal, most common, and expected execution flow. Everything goes as planned, inputs are valid, and the program behaves exactly as intended. It's the scenario you primarily design for. Sad path, error paths. These are scenarios where something goes wrong. It could be invalid input, network failures, resource unavailability, or any other unexpected event that disrupts the happy path. Sad paths must be handled gracefully to prevent crashes, data corruption, or incorrect behavior. Corner cases. These are less frequent, often edge case scenarios that test the limits of your code. They might involve extreme values, boundary conditions, or unusual combinations of inputs that are technically valid but could lead to unexpected or incorrect results if not handled carefully. Corner cases often expose subtle bugs or limitations in your implementation. 2. Why are happy paths, sad paths, and corner cases important? Robustness and reliability. Addressing sad paths and corner cases makes your application more robust. It prevents unexpected errors from crashing the application or causing data loss. User experience. A well-handled sad path provides informative error messages to the user, guiding them on how to correct the problem, improving the overall experience. Security. Corner cases can sometimes be exploited to bypass security measures. Proper validation and handling of edge cases help prevent vulnerabilities. Maintainability. Thinking about these scenarios early helps you write cleaner, more maintainable code. Error handling logic becomes an integral part of your code instead of a tacked-on afterthought. Testability. Identifying happy paths, sad paths, and corner cases is crucial for writing comprehensive unit tests. Tests should cover all these scenarios to ensure the code behaves correctly under various conditions. 3. Identifying happy paths, sad paths, and corner cases. The key to handling these scenarios effectively lies in identifying them during the design and development phase. Here's a step-by-step approach. 1. Define the functionality. Clearly state what the code is supposed to do under ideal circumstances, the happy path. What are the inputs, the expected outputs, and the logical flow? 2. Brainstorm potential errors. Consider all the things that could go wrong. Ask questions like what happens if the input is invalid, wrong type, out of range, null, empty? What happens if an external resource, database, API, is unavailable? What happens if there is a network failure? What happens if the user doesn't have sufficient permissions? What happens if the system runs out of memory? What happens if the user provides contradictory information? What happens with concurrent access, for multi-threaded or asynchronous systems? 3. Identify corner cases. Think about edge conditions and boundary values. What happens if the input is at the maximum or minimum allowed value? What happens if the input is an empty string or an empty collection? What happens if the input is a duplicate value? What happens if the input is a very large value? What happens if the input has unusual characters, example control characters, Unicode characters. Asterisk what happens if a loop iterates 0 times. Asterisk what happens when dealing with extremely large files or data sets. 4. Prioritize and document. Prioritize the errors and corner cases based on their likelihood and potential impact. Document your findings in code comments, design documents, or test plans. 4. Handling happy paths, sad paths, and corner cases in code. Let's illustrate how to handle these scenarios with code examples in Python. Explanation asterisk. Asterisk happy path asterisk the calculate underscore discount function first attempts to convert the inputs to floats, allowing for string inputs that represent numbers. If the inputs are valid, it calculates the discount and returns the discounted price. Asterisk sad path, error handling. Asterisk input validation asterisk the code checks if the price is negative and if the discount underscore percentage is within the valid range, 0 to 100. If either of these conditions is true, a value error is raised with an informative error message. Asterisk type validation asterisk the code uses a try except block to attempt to convert the inputs to floats. If the inputs are not numbers, a value error is raised, which is caught, and a type error is raised to indicate a type-related error. Asterisk try, except blocks asterisk the try, except block is a fundamental mechanism for handling exceptions in Python. The code within the try block is executed. If an exception occurs, the execution jumps to the except block that matches the type of the exception. Asterisk corner cases asterisk. Asterisk 100% discount asterisk the function handles the special case where the discount is 100%. In this case, the discounted price is 0. Asterisk note that other corner cases, such as very large prices that could lead to overflow in discount underscore amount calculations, are not covered in this simple example but may need to be addressed in a real-world scenario. Best practices for handling errors and corner cases. 1. Fail fast asterisk validate inputs as early as possible to catch errors before they propagate through the code. This makes debugging easier. 2. Use exceptions asterisk exceptions are the standard mechanism for signaling errors in many programming languages. Use exceptions to indicate that something went wrong and to break out of the normal execution flow. 3. Provide informative error messages asterisk error messages should be clear, concise, and helpful. They should tell the user what went wrong and, if possible, how to fix it. 4. Handle exceptions appropriately asterisk don't just catch exceptions and ignore them. Either handle the error gracefully, example by retrying the operation, providing a default value, or logging the error, or re-raise the exception if you can't handle it at the current level. 5. Use logging asterisk log errors and warnings to a file or a logging service. This provides a record of what happened and can be invaluable for debugging and monitoring the application. 6. Write unit tests asterisk write unit tests to cover all happy paths, sad paths, and corner cases. This is the best way to ensure that your code behaves correctly under all conditions. 7. Consider defensive programming asterisk defensive programming is a coding style where you anticipate potential problems and include code to handle them proactively. This includes input validation, error handling, and assertions to verify that your assumptions are correct. 8. Use assertions asterisk use assertions to check for conditions that should always be true. Assertions are useful for catching programming errors and debugging. Assertions are typically disabled in production code, so they should not be used for error handling. 9. Graceful degradation asterisk if a feature is not critical to the application, consider allowing it to degrade gracefully in the event of an error. For example, if a recommendation engine fails, the application could simply skip the recommendation section instead of crashing. 10. Use configuration * make your error handling configurable. For example, you might want to control the level of logging or the number of retries for a failed operation through configuration settings. 11. Don't catch and rethrow without adding information *. If you catch an exception only to rethrow it, ensure you add value by including additional context or wrapping it in a more specific exception type relevant to the current operation. Avoid swallowing the original exception's information. 6. More advanced examples. Let's look at a slightly more complex example that involves network requests. Explanation ****. Happy path ***. The code makes a GET request to the API endpoint, checks if the response status code is good, using response.raise_for_status, parses the JSON response, and returns the data. *sad path ***. Network errors *** the requests.exceptions.request exception is caught, indicating a network problem. The error is logged, and none is returned. Invalid JSON ** the JSON.json decode error is caught, indicating that the API returned invalid JSON. The error is logged, and none is returned. HTTP errors ** if response.raise_for_status detects a 4xx or 5xx HTTP error code, it raises an exception. This is caught, the error is logged, and none is returned. Corner cases ***. API downtime ** what happens if the API is temporarily unavailable, example during maintenance. Consider adding retry logic with exponential backoff. Rate limiting * what happens if the API rate limits your requests? Implement logic to handle rate limits gracefully, example by waiting and retrying. Empty response * what happens if the API returns an empty response? Make sure your code can handle this case without crashing. Large data sets * if the API can return very large data sets, consider using streaming to avoid loading the entire dataset into memory at once. 7. Testing. Testing is critical for ensuring that your code handles all scenarios correctly. Unit tests * write unit tests to test individual functions or methods in isolation. Use mocking to simulate external dependencies, example databases, APIs. Use test-driven development, TDD, to write tests before you write the code. Integration tests * write integration tests to test the interaction between different parts of your system. Integration tests can help you find errors that are not caught by unit tests. End-to-end tests * write end-to-end tests to test the entire application from start to finish. End-to-end tests simulate real user interactions and can help you find errors that are not caught by unit or integration tests. Test cases * create test cases to cover all happy paths, sad paths, and corner cases. For each test case, define the inputs, the expected outputs, and the steps to execute the test. Automated testing * use automated testing tools to run your tests automatically. Automated testing can help you catch errors early and prevent regressions. 8. Summary. Handling happy paths, sad paths, and corner cases is essential for writing robust, reliable, and maintainable software. By identifying these scenarios early in the development process and implementing appropriate error handling and validation techniques, you can create applications that are less prone to errors and provide a better user experience. Remember to write thorough unit tests to verify that your code behaves correctly under all conditions.